look at, say, number 10. Is that doable? And we got the square of tan plus cotan. Well, those are reciprocal, right?
Sorry.
So is it true that no matter what value of x we choose, as long as these things are all defined, tan and cotan, that means neither sine nor cosine is 0, right? Then you get secant squared x cosecant squared x.
Chapter 7. Right? This is the very ending, right, of the book, of the chapter 7?
Yeah, I'm just going to the review.
Chapter 7.
Yeah.
Oh, okay.
So what would be the best term
So yeah, I would expand the left side.
This is the... Okay. Yeah.
So the question, are these always the same? No matter what value of x we choose, as long as it's not north, south, east, or west, right? Where sine and cosine could be 0, or cosine. All right, do you see how I got that 2 there?
Can you show it? Because
Well-
we pretty much, we put them, we multiply them together, yeah.
Yeah, tan times cotan, well, those are reciprocals, right? So when I multiply them together, I get 1,
There's two.
and there's 2 of them.
Okay.
Right. All right, so I could take, this and say this is secant squared minus 1. Would that help?
Secant squared
Is that true even?
Yeah, that'll help.
Yeah, that's right. How about this?
Oh, +1,
Cotan, who remembers cotan? That's,
it's,
so if you forget one of these, it's easy to develop them, right? Just say cosine squared x plus sine squared x, that's easy to remember. And then if I divide through by sine squared, right? I get cotan squared plus 1 is equal to cosecant squared.
So cosecant minus 1. Cosecant
that?
squared x minus 1.
Okay.
Yeah, so cotan is going to be cosecant squared minus 1, huh? Is that always the same as secant squared times cosecant squared?
I would say so, yeah.
Well, I'm going to get cosecant squared plus cosecant squared, huh? Get the same thing if I multiply them, if I add them? This is still questionable, huh?
Yep.
So how did you just like combine them? And then you got the secant squared x plus cosecant squared x? Oh, okay, I see, I see.
You see the minus 1, the
Yeah.
minus 1 is a
So you-
minus
you-
2.
Yeah, you combine them.
Cancels that out, right? Well, yeah, I mean, I think the trick here would be to write this in terms of cosine, right? So this is 1 over cosine squared x plus 1 over sine squared x, is that right?
Yes.
Okay, and then over here we'll have 1 over cosine squared x times sine squared x, right? Are those the same?
No.
No.
Seems odd that you get the same thing if you add these and if you multiply them, huh? Common denominator, right, I was waiting for that. Okay, good. So if you build this up,
It'll be sine plus.
yeah, you'll get,
Oh, it'll be one.
yeah, there it is, amazing, huh?
Mhm.
That's so now it's obvious.
Both sides. So they give you sine squared.
And I did work with both sides. I worked mostly with the left side, but in the end, I wanted to bring them together in terms of sine and cosine rather than cosecant and cosecant.
So you just multiply them by cosine squared x.
Yeah, build up a common denominator on the left side. Okay. What else is good here? About 14. New identity. So, 1 plus tan x times tan of x over 2. Is that the same secant x? For all x, right? Again, it's an identity. So we'd like to say as long as secant and tangent are defined, then these should be the same. Well, we've got a number of identities for, what do you do about tan x over 2? Do you remember those? Plus or minus 1 minus cosine x over 1 plus cosine x? Is that memorable?
Oh, is there a trick like you did on the left that derives that on the right?
I'm sorry, what?
So you're saying, is there a simple trick like you did on the left to derive what you did here on the right with dividing by sine to get the cotangent and secant?
So it means here to here, or here
Yes.
to here?
No, up top,
here?
yep.
Yeah, so this, okay, so if you don't remember this, you can rebuild it from, the most fruitful of all identities is the double angle identity for cosine. So cosine 2x has 3 different versions, right? Where this one comes from just plugging into the addition identity x plus x, right? This one comes from replacing sine with 1 minus cosine squared, or sine squared with 1 minus cosine squared, and or you could also replace cosine squared with 1 minus sine squared and get either one of these, right? So then that says that, cosine of x is equal to twice cosine squared of x over 2 minus 1, right? Which, when you solve for cosine squared of x over 2, you get 1 plus cosine x over 2. And so then cosine of x over 2 is either the positive or negative square root, depending on what quadrant you're in, right? Similarly, so that's if you use this one, right? Similarly, you can say sine squared x over 2 is equal to 1 minus cosine x over 2. Notice I'm replacing, here I'm replacing x with 2x with x and x with x over 2. So maybe I should use a different name, right? So I'm saying wherever I see 2x here, I'm going to replace it with x, and wherever I see x, I'm going to replace it with x over 2.
Not because you divided by 2 on that?
Yeah, because it's a half angle. I want the half angle formula, so. These are equivalent statements, right? So that gives me sine of x over 2 is equal to plus or minus the square root of 1 minus cosine x over 2. Then when I put these two things together, I get that, right? Tan is sine over cosine, and when I take the ratio of those things, the 2's cancel out, and the ratio under the radical is the radical of the ratio. Right? So the radicals come together as a single radical, And so now this, if I multiply by 1 in the form of square root of 1 minus cosine x over 1 minus cosine x, I get 1 minus cosine x over sine x. Because it's going to be the square root of 1 minus cosine squared. The square root of sine squared, which is sine. So that could be useful here, huh? So let's write tangent as sine x over cosine x. And write tan of x over 2 is 1 minus cosine x over sine x. And then we see the sines cancel out. And we still want to say this is 1 over cosine x, right? Which is the same as secant. Does that work out? So this is going to be 1 plus 1 minus cosine x over cosine x. Is that the same as 1 over cosine x? What's the trick there?